And welcome back. In this video, we're going to be creating yet another example to take advantage of events. The idea is to create our very own custom timer class. Why would we want a timer class, Logan?
Well, we could use a timer class to cause something to happen at a given interval. So in any time where we would like to drive something in the scene at a given timed interval, a timer could be very handy because up until now, we've driven things either based off of the current frame rate or as time passing as a continuous thing, basically smooth continuation. A timer can be set up to fire off single calls at a given interval. So if we want to have a blocky-looking advancement, like let's say we want to have a stair-step effect that advances one step at a time, we could set up a timer with an interval to drive in to have the desired functionality happen at the given interval.
But Logan, we've created timing systems in the past, like with precision, how we had the health bars and things like that.
And that's actually very good because our new timer is actually going to use a very similar timing mechanism. What's ended up happening is we've used that timing code quite a bit in all of our projects. As a matter of fact, even the animated sprite uses some of it. And it gets to the point where it would be very convenient if we could have a single class that used such timing code and allow it to drive everything timing based, meaning if in the future we ever have a power-up that has a given amount of time that it can run, it'd be nice to have that time allotted be given by a timer instead of having to use the same timing code in a myriad of different classes.
That's right.
It'll make it more efficient because now we can consolidate the timing mechanism to an actual timer. But in this case, the reason we haven't done that in the past is, well, then our timer would be locked to doing only specific things. We need a power-up timer and a ship timer and a stairs timer. But if we're using an event, we can have the timer simply fire off an event blindly. It doesn't really know what that event's going to be, but the key is it can cause it to happen. So that means from the outside of the timer, we can use the timer as a mechanism to drive timing, even though the timer doesn't know about the functionality that it is driving.
Exactly. Now, the application that Logan's going to be putting together to demonstrate this custom timer class is going to be something like this. Basically, Logan's going to create a button. Actually, he's already got a button made. It's going to be a white circle that we're going to be able to modulate to get a predetermined color. And we're going to modulate it to get two different colors depending on the state of the button. So we'll have one where it's going to be basically a light shade of gray, or we'll have another instance where it's going to be shaded a light green color. So again, the idea of this one button will be visualized in two different states, whether it's going to be a light gray or a light green, okay, or a gray or light green. Now, the button itself is going to manage its state. It'll be able to be told to be toggle, and if it's gray, it'll toggle to a light green. If it's light green, it'll know to toggle to gray.
And what's convenient about that is we can have it manage its own state internally in that manner. So we can blindly call toggle, and we simply let the button worry about what state it's currently in, meaning that if it's gray, it needs to switch to green. If it's green, it needs to switch to gray. So the toggle allows us to turn it on and off without having to remember its state.
That's right. Now what we're going to do with that button, since we've just given you a demonstration of it above, is we are going to create 5 of these in a row. So 1, 2, 3, 4, 5. And we're going to set up a problem before we come up with the solution. And the problem is going to be basically where we can go in there and drive these guys toggling in a predefined order via a key press on the keyboard. And here's how it's going to work. Logan's going to hit a key on the keyboard, and we're going to toggle from a gray to a green. So this guy will toggle first. Then Logan's going to hit the key again. This guy will toggle. Hit it again. This guy will toggle. So they all start out gray, and you'll notice that now, as Logan continues to press the key on the keyboard, they toggle to a light green. We're going to use an internal tracker to basically track where we're at, so it'll know which one to toggle when Logan presses the key. When we get down to the end, the tracker is going to basically loop back and point back to the beginning, so that when Logan hits the key yet again, what's going to happen? Well, it's going to toggle this back to the gray. Then the tracker is going to advance. Logan presses the key again. This guy's going to toggle back to a gray. Then this guy, then this guy, and then finally this guy. And once again, if he presses the key yet again, well, we're now pointing back here, so this guy is going to toggle. So you can see how basically it lights, unlights, unlights.
So it's almost like a marquee scrolling effect but in individual lights.
That's right.
You may be asking yourself, what is the point or what is the end goal of this? And really, the only reason we've created this is to give an animated visual example of something that we wanted to time. The whole key about this is I want to be able to control the rate at which these lights activate and deactivate.
That's right. So we're going to demonstrate the setup where Logan's going to control it manually, and then we'll take the timer class and we'll drive this with the timer class.
Exactly, because the manual key press is only going to let us verify that our tracking code is working. It's just going to make sure that we move button by button, turn them on, and then turn them off in the proper sequence.
Exactly.
And once we've got that, then we still need a mechanism for timing, and that's where we'll get into the timer class itself.
Okay. So with that, let's go ahead and jump on over to Visual Studio and get started.
All right. Well, let's begin with a new project, and let's call this project Timer. And inside of our new timer project, let's first begin with the button lighting setup. Let's get that tracking system in place. Let's get 5 buttons in place and make sure that we can cycle through them using a key press.
Okay.
Now the button itself is going to be an image, and I have just such an image over here in our working folder. If we load this button, we see nothing because it is a white circle, and the image viewer is going to give us our transparency on a white background, so we can't actually see what the image is.
But trust us, it's a white circle.
But rest assured, it is a white circle with transparency, and that allows us to give us a predictable result when we modulate the color. So if I copy that image, we can drop it into our solution. If I go into the contents of project and paste it in, we have our button. So the next thing I want to work on is an actual button class. The class that's going to manage some colors and the state of the button. So let's add a new folder called classes, and let's add a new class called button. Now inside of this class, I'm going to set up a few using statements because we are going to need some XNA types. We're going to need, and we're also going to need some graphic stuff. We'll need to have a color type. So I'll throw these in as using Microsoft.xna.framework and framework.graphics. I'm also going to remove the text namespace because we won't be using that at all. I am going to leave the collections using in place, because I'm going to have these buttons manage themselves in a static list.
Okay.
And of course, next thing we want to look at is the classes of namespace, which we'll remove so that everything exists in the same timer namespace. Now, inside of the button class, we need a series of fields to keep track of everything. First is the static list of buttons, so that we can always manage an arbitrary number of buttons. So I'm going to make a public static list of type button, and we'll call this list buttons. And I'm immediately going to turn around and initialize it with a field initializer here, and that just prevents me from having to go in and make a static constructor to initialize it. So this will be a new list of type button. Now we need a few fields to manage the state of this button. And we had discussed things like it's going to need to remember or need to know about colors. It's also going to need to remember its state, whether it's active or not. One other thing that I'm going to have button manage is a position. So each of the buttons can have a discrete position on screen. So we'll begin with that position field. So we'll have a public vector2 called position. And then we'll have our colors and active. So what I'm going to do for color is I'm going to make in this case, this will be a little bit interesting. I want to make the ability to have, or the button always has a color, so that at any moment at render time we can look at the button and just ask it what its current color is. But I'm going to access that through a property, because internally the button knows that it could have different colors. I'm going to store those colors in an array, but when it's asked about what color it is, it's only going to return one of those depending on its state.
Gotcha.
So I'm going to make a private color array, which I'll name colors.
Yeah.
And I'll initialize that with a field initializer as well. And colors will contain 2 colors, gray and light green. So color.gray can be element 0, and color.lightgreen can be element 1. So that should take care of the initialization for colors. And one more thing we need to remember is the current state of the button, active or not active. So I'm going to make a private boolean called active. So moving on from here, one more field I want to add, this being a property. since we know we can have these two colors as possible colors, I want to give a property so that any moment the button can be asked what color it is right now and have it return a color based on its active state. So I'll make a public color property, and I'll call that property simply color. And to this property we'll add a get accessor, and the get accessor is going to do a check. If we're active, it'll return color sub 1. If we're not active, it'll return color sub 0. So if we are active, then return colors sub 1. Otherwise, return colors sub 0. And that should allow us to always grab a current color at any given moment. So moving on from here, that takes care of all of our fields and our property. So let me set up a public constructor just to make sure that the button gets added into the buttons list. So I'll have public button, and whenever we create a button, we'll make sure that the current button goes into the buttons list. So we will add this instance. And one last thing the button needs to be able to do is each instance needs to be toggleable. So I'll make a public void method called toggle, and toggle will simply reverse the current value of active. So I'll set this.active equal to not this.active. And with that, that takes care of a very simple button class. It can be toggled, manages its state, and returns a color based on that state. So if we build, make sure that there are no errors, and active is spelled wrong somewhere. A-C-T. Alright, so spelling aside, everything is working good. The only thing remaining is a warning about the yet unused position. So now that we have a button class, let's go into the game and let's start creating some buttons. So the first thing I want to do inside of our game is set up a texture field. Since you'll notice I wasn't storing a texture reference inside of individual buttons, we simply have one we'll know about from outside. So the only important thing coming from button is color. That means out here inside of the game, we'll have a texture2D class, and I'll call this something like button texture. And let's see. I guess before we move on, we could go ahead and get that texture loaded in. So if we jump very briefly down to load content, we could take our new button texture and load from the content manager. And again, loading a type of texture2D. The asset name will be button. So now that we have this button loaded in, we could go ahead and set up the drawing code necessary for buttons. Since again we've got that buttons list we can now access from the button class. So down here in draw, I am also going to change the color from being the default color of cornflower blue over to a color of black. Reason being is because of that gray and light green color, those show up much more clearly on a black background. Now as for the drawing, this will start off as a standard called sprite batch begin and end, of course. Now, inside of our called sprite batch, we want to loop through each existing button and draw to the screen. So I'll use a for each loop and drop that in with the template. And the type we're looping through here is button. So for each button, we'll call the individual variable button, and the collection is going to be button.buttons, so our buttons list. Then for each button, we can now call our sprite batch and tell it to draw. We'll be drawing using the button texture. The position is given by the button itself, so we look at the current button dot position, and the color will be a color given also by the button. So if we look at our button, we have our color property, and we'll feed that along to the sprite batch as a draw call.
So go ahead and throw a terminator in there real quick.
Okay, get that terminated. Now if we build, there are no errors. If I run right now, everything should run, but of course we see no buttons because we haven't created any. So let's go up to the initialize method and create some buttons. We said we wanted to create 5 buttons, so to speed this process, I'll make a for loop, and we'll loop up to the value 5. So loop to the number 0 through 4, giving us 5 buttons. So inside of this loop, we'll create new buttons. I'll actually declare each button as a local variable to give us control of it after it is created. So I'll make a button variable, and that will be equal to a new instance of button. Then we can turn around and use our new button and position it somewhere relevant on the screen, because of course I don't want each of these buttons created over each other, because then we won't be able to see the effect. So this new button's position will be set to a new vector2, and we'll set x. We'll progress to the right in x so that it lines up with the same thing as drawn on the whiteboard. So for x, we'll actually take the value I, then we'll multiply it by about 48, so we get the width of the overall graphic and then some. And the value in y, we can start that off at 0. And if we run now, we can see we have 5 buttons. But I would like to specify a little bit more of an offset just so it looks nicer and isn't so squashed up to the side of the screen. So to offset in y, that's easy. We can just add 10. And in x, well, essentially we can do the same thing. We could, after gaining the calculation against 48, we can then append or offset by 10, giving us a value, or excuse me, an offset in 10 and 10 in x and y. So now that we have these buttons, let's set up a way to toggle them. Because of course, right now, just to show what toggle is doing, if we took each new button and told it to toggle after creation, now all of our buttons are on because they're immediately toggled on right after they're created. But the idea is that we want to be able to toggle them individually and then set up a tracking system so that we toggle and then move on to the next button. If we reach the end of the buttons, we loop back around to the first button. In order to do that, I'm going to add a button index variable. So here in our game, we'll make an integer called button index. And right after we do that, I'm going to make a new method called press button. So I'll have a method that we can invoke that causes the current button to be pressed and then moves that tracking variable. So I'll make a private void method called press button. And what press button is going to do is it's going to look at the current button and toggle it. So what is the current button? Well, we'll use button index in conjunction with our buttons list and toggle whatever button ends up coming up from that calculation. So if we look into the button class, we have our buttons list. Buttons can be addressed by index, and we can feed in button index into our array.
But that's button texture.
Oh, whoops. Okay, that wouldn't work very well.
No.
Button index would probably work a lot better. So looking at a specific button, we can then call upon its toggle method.
Cool.
Now, after we have toggled a button, we want to advance our button tracker. So I'll take our button index variable and increment it. Now the problem with this is this will work fine for 5 button presses, but if we keep incrementing the tracker, we'll eventually go out of range of the buttons list and cause an exception. We need to make sure that if the button index goes beyond a certain value, it wraps back around to 0. So really, we could probably just do an if statement check. I'm actually looking at, there's 2 easy ways we could do this. We could do an if statement, or we could do something against modulus. Here, for whatever reason, I feel like doing the if statement method, because this isn't really the focus of anything. This is just making the whole variable reset. If we take our button index and check it, let's say if button index is greater than button dot buttons dot count -1, then we know we've gone past the overall range that we need, and we'll take button index and set it back to 0. So if we build, there are no errors in that, and we can prove that it's working by going in here very quickly right after we create all the buttons. If we now call press button, we should see only the first button light up. And we do. Now we could add as many calls as we want here. If we add 2, then 2 buttons will light up. But it would make everything a lot easier to see if we could do this real time. And to do that, I'm going to go down to the update method and set it up so that every time we press a key, maybe the Z key, we'll set that to call the press button method, and will allow us to test everything with a much greater clarity. Now the only problem with using a button or a key press directly here is we're only looking at the key's state, meaning if we hold the button for more than a 60th of a second, we'll light up more than one button. So I do want to be able to remember the state of this button so that one key press equals only one call to the press button method.
Exactly.
And to do that, since I'm going to consider this part just temporary code, I'm not even going to go up to the top of our class. I'm instead going to declare a field right here called key down and set it to false, so that I can turn around and use that in here in conjunction with, excuse me, let me put a type to that. Let's make a boolean called key down and set that to false right above the update method. Then I want to do a check on the Z key. So I'll look at the keyboard and get its current state. And if that state's key, we'll run an is key down for the Z key. So if the Z key is in fact down, then we'll do the following. So if the Z key is down, we need to do another check. We need to see if the current key was already down. So basically only on the first time that it was down. So if not key down, then we can go ahead and invoke the method. So we can call press button. Then we can also turn around and remember that key down was pressed. So we'll set key down equal to true. And if the key is not down, we need to remember that key down was false. So we'll put in an else after the key is checked. And if the key is not down, then key down value will be set to false. And all this may seem a little bit odd, but really all this code is doing is the same thing as we've done in the past when we have stored a last keyboard state field. Same idea there, only in this case it only works for a single key because we're only remembering enough information for one key. But in this case we'll also only need because we're only looking at the Z key. So if we run now and press the Z key, one button lights up. If we press it again, then we get two. So we can light up all of the buttons in that manner. Once they're all lit, we can check the wraparound code and make sure that the first button deactivates. So basically our button trackers move back to the first button and turn it off by toggling it. So we can toggle all the buttons back off. And then the cycle continues. So you can see if you press the key at a relatively regular rate, then you get a sort of animation where all the lights light up and then turn back off in sequence.
Okay.
So now what we'd like to be able to do is, I know this is off on a tangent, but I'm actually going to optimize this just a little bit.
Okay.
It suddenly occurred to me as I was coding that it would be a little bit easier to reset the button index using modulus. So instead of running a branch, we could instead say button index modulus equals number of buttons. And that should reset it. The reason I wanted to hold off on actually changing that is if I have placed an incorrect count here, we can test by running and make sure that we don't run out of sequence. But we can in fact hit all of them. That was just in the back of my head bothering me because we could do that as a much more simple numeric operation instead of running a check. But all's good. And press button still is the exact same thing. We simply reset our counter back to its original place. Now that we have all functionality that we would like for our button lights, we need to put in the automated timing system. And that timing system is going to consist of a timer class. Now, as we discussed very briefly, that timer class is going to use events in order to separate it from the we can separate the timing code from the actual invoked code. So before I create the timer class itself, I'm first going to create another small code file to contain the delegate that it will be using for its event. The reason being is that I want to use a very simple delegate, so I'll simply use a notify handler with no parameters. And that way the timer doesn't have to worry about calling anything. Because in this case, since we're looking at the timer from outside to begin with, in order to specify functionality, we already know who the timer is because we told it to hook up the event. So we're not going to worry about what was calling the event. So into classes, I'm going to add a new item. I'm going to simply create this one as a new code file.
Okay.
Because, again, the only thing declared inside this file is going to be the delegate itself. So I'm going to call this file events. And we'll declare one event. Now, of course, this being a new code file means we get a completely blank screen, but all I need to set up here is our namespace, where the namespace is going to be timer, matching the namespace for this project. And inside of namespace timer, we'll create the delegate. So I have a delegate void notify handler. And notify handler is going to take in no parameters, and that wraps up the declaration of this delegate. Now that we have the delegate itself in place, we can write the timer based around this handler. So we can go back to classes and add a new item. This time we'll add in a new class, and I'm going to call this timer. So we have our new timer class. Now I'm going to take out the usings for collections and text, as we won't be using those inside of the timer. And very briefly, I could jump over to button to steal 2 lines, the using statements for framework, and I don't think I'm going to be using graphics inside of the timer, so we'll take that back off. Alright, now for the timer code itself, Well, before we can use it, we should probably strip off the class's subnamespace so that we can access it. Alright, now for the timer itself. The things that we're going to hold in here are very simple. In the past, the most common timing mechanism we had used revolved around two fields. We would have a variable or a value called interval and a value called time remaining. And the idea is that interval was the master, like I guess you could say master default for the amount of time that should pass. Time remaining was initialized to the interval, and then as time passed, we chipped away at time remaining. So that way that value got smaller and smaller until it reached 0, and once it reached 0, we considered ourselves to be out of time and ready to fire off the event. Only we weren't using that terminology or code in the past. But here we can use just such a timing system, but we'll be watching for that time, and then the code that should happen is the actual firing of an event. So that means in addition to these values, we'll also need to hold an event as a field within the timer class. So both of the timing fields are going to be private, and both will be of type double, just so we can natively use the times or the types returned by game time when accessing the number of seconds that have gone by. So I'll have a private double first for time remaining, and another private double for interval. Now the event is of course going to be public. We'll have a public event of type notify handler, and we'll call this event fire. So you could say whenever the timer fires is when its event occurs. Now, inside of the class, there's only really two methods we need to put together, and the first is just the public constructor. The reason we want a public constructor is we have made the interval private. There's no way to access that interval. We're going to set up this timer to be a very, very simple timer. Its interval will be set upon creation. So I'm going to make a public constructor that is going to take in the interval. So I'll make a public constructor, and the constructor is going to take in one double parameter called interval. And inside of this constructor, we simply initialize interval. So this dot interval will be set to the given interval. And we'll also initialize time remaining. And the reason we're going to do this is so that upon creation, the timer actually has to count down its interval before it fires. Otherwise, the timer is actually going to fire its event the moment it's first updated. So we'll make sure that we initialize time remaining also, and to the same value of interval. So that takes care of timing value initialization. The next thing we need to do is to set up an update method so that the timer can function. And this will be a public void method called update. An update is going to need to take in a game time. So we have a game time parameter. And now inside of update, we want to first chip away at the time remaining value. So this dot time remaining will be decremented by the amount of time that has elapsed. So we'll look at game time, we'll query the elapsed game time, and we'll look at that time in seconds, so as total seconds. After we do that, we'll do a check and see if our time remaining has expired. Has it crossed or gone less than 0? So if this dot time remaining is less than or equal to 0, then we have run out of time. And if we've run out of time, we need to go ahead and fire off our event. Now, once again, we do want to make sure that this event has been set up before we attempt to invoke it. So we'll begin with a check to see if this dot fire is not equal to null, then we will invoke the fire method, or excuse me, the fire event. I guess in the end, once it's all linked up, it'll be the fire handler, but on the outside, we probably won't even use, well, yeah, we'll use the word fire to access it, but we'll probably have that linked up to, I don't know, maybe button press, or press button. Now, after we fire off the desired functionality, I also want to make sure that our time remaining gets reset so that we continue counting down for another iteration.
Right.
So I'll take this dot time remaining and reset that back to the interval for the timer. And
so for most of you guys, this should look very familiar.
Exactly. Same, almost identical timing code, but this time the entire class's purpose revolves around timing. The only thing non-timing related is this event.
Right.
That means everything action-specific can be specified outside of timer. And as a matter of fact, we can go ahead and take a look at that right now. I will build very briefly just to make sure that there's no errors we have to come back to. So everything has worked. So let's turn our attention back to the game class. So we would like our new timer to control our press button method. And to do that, I'm going to go into initialize, and we'll set up a timer. As a matter of fact, in order to remember that timer for more than one method, we should probably first make a field. So if we go back into our class, we can make a timer field called timer. Then inside of initialize, we'll create our timer. The timer will be equal to a new instance of timer. Of course, timer requires an interval in order to be created, so let's start this off with an interval of a half a second. So value 0.5. And then we'll turn around and make sure that we set up a handler for the fire event. So we'll look at our timer, and we'll set its fire. Matter of fact, we'll subscribe to fire with a new notify handler. And that notify handler is going to be based on the press button method. So all of that linked up. And of course, you'll notice that when we had created press button, even though I didn't point it out, it does in fact match the method signature of the notify handler delegate here. No void return type and no parameters. But with all this lining up, if we run right now, we wouldn't see any effect because timer isn't ever being updated. So we've set it up, and down here in update, we need to make sure that we update the timer. So timer.update, feed in our game time, and now we can run. So now we're watching all the buttons light up and then fall back out.
Nice.
So now we have precise timing control and can set it arbitrarily however we want. So if we go into our timer and we wanted that a lot faster, we could do maybe half of that, a quarter second. Or we could go in and even make it an eighth of a second. And then tweak the result however we want. And now it's very cool here because we could have, when we've now defined an effect entirely outside of the world of timing, we've just defined how it works. Things light up in sequence, and things unlight up in sequence. Mm-hmm. But the timing is driven by a generalized system, a timer, and we were able to set up the timer class because of the power given to us by events. So basically, we can set up a timer class, and the timer class's only purpose is to track timing code. But because we had set up an event for the timer, we could keep its functionality very general, where all the timer knows is that it is going to be firing an event, and it's not worried about what that event is. It's only worried about the fact that that event is in fact set to something. That's where we did the check before we called it.
Right.
That means outside of the timer, we can make a timer and use it to time arbitrary things in our code. All we need to do is meet the requirements of the notify handler method signature, and we can have any code we want invoked by the timer. And really with that, I think that's going to wrap up this lesson because we've got everything covered. We have our effect and our timer to drive the effect.
Okay, well that'll wrap things up. Thanks a lot.